back again. So we got logarithmic function properties. This time we're going over what's called the product rule. Okay, this one's a little bit more difficult than the other rules, but remember, you don't need to worry about the proof so much, just worry about the rule. The rule itself's not hard, but the proof is hard. That's what I should have said. Proof is hard, but the rule is not that bad. Okay, so here we go. So say you have a problem where it says, y is equal to log base a, and then there's two numbers that are being multiplied together. Okay, what the product rule is basically going to show is what to do to simplify your life when you see these two numbers multiply together. The first thing we're going to do is we're going to raise both sides to the a. We're going to take the we're going to make a the base of both of these sides for the exponent. So I'm going to do a and raise it to the power of whatever's on this side. So y, and then I'm going to do a and then raise it to the log of a. Log base a of x times m. Okay? If you remember from our basic properties of logarithms, this will cancel right here, and then xm will drop down. So we're going to have a to the y power equals xm like so. Okay? Now to solve this problem, we need x and m to both have a base of a. They don't have a base of a right now. Okay? So I'm going to make it so they do. So what I'm going to do is say that, let's just say x is going to be equal to a to the g power. I'm just making something up. It doesn't actually matter what it is. I'm just making it up as long as the base is a. And this one I'm going to say it's the h power. Okay? These two variables could be any variable as long as I didn't use them over here already. Okay, so I just raise this one to the g power and this one to the h power. And now I'm going to substitute that in here because it'll help us solve it. Trust me. So a to the y power equals a to the g power times a to the h power, right? X times m, these are x and m, so just multiply them. Okay, from here, based on your basic exponential rules, is that all you have to do is add these two exponents up, g plus h. Okay, so a to the y equals a to the g plus h based on these right here, this rule that I made, not rule, that I substituted in for x and m. Okay, from here, I'm going to take the log base a of both sides. Okay, so you end up with y is equal to g plus h. So it canceled out those a's. I took the log base a of both sides. It canceled out the a's, dropped it down. Now what we need to do here is g plus m. We need to have this in terms of x and m because that's what we started with. It has to be in the same terms as that. So what we're going to do is we're going to resubstitute it back in, but we need to solve for what g is equal to and for what h is equal to. Okay, well if a to the g is equal to x, based on our log rules, we should know that g is equal to log base a of x. Right? I took the log base a of this side, log base a of this side. A is canceled, you got g. And m, same thing, log base a on both sides. So then you have m equals log base a of m. This should be an h. Confusing myself here. Take the log base a of both sides, you get h, and then log base a of m. So what I'm going to do is substitute this in. G is equal to log base a of x plus h is the log base a of m. And now you're like, well, so what? Well, watch this. Y is equal to log base a of x times m. So I'm going to do right here, log base a of x times m. And you end up with a fancy product rule. Okay? You have log base a of x times m. It's the same thing as log base a of x plus the log base a of m. This will simplify your life a lot when you're solving logarithmic problems. So this proof doesn't matter so much. The most important thing, again, is this rule. You're going to need this to solve some of the logarithm problems. Hopefully this helps understand this a little bit more. Let me know if you have any questions.